Hello and welcome. Today, I'm going to share to you how to tackle um, questions about stoichiometry. As you know, that stoichiometry is actually relating to the amount of something. All right. So, for example, um, mole, right? And then I'm going to introduce to you also concentration, and then I also have a volume at STP, or it measure at RTP. And then it can be also the number of particles. All right, number of particles. All right. So for mole, right? So let me start mole. Um, Instead of explaining to you one by one, I'm going to show you this chart. So mole, if you wish to convert mole to mass, all right, you just multiply by mR. So mole times mR equal to mass. Okay, that's how you read it. And then if you wish to convert mass to mole, then you need to divide it mass to mR. So mass divided by mR equal to mole. All right, is that clear? Next, if you wish to convert mole, all right, mole to volume at RTP. RTP stands for room temperature and pressure. So you need to multiply by 24. The unit is actually the MQ per mole. All right. And then if you wish to convert volume at RTP to mole, just divide it by 24. Okay, 24 the M cube per mole. Okay. If you wish to convert mole to concentration, so you need to divide it mole by volume in the M cube. All right, so mole divided by the volume equal to concentration. So that's why the unit for concentration is actually mole per dm cube. Okay, so this one is actually gram. Right. Now, if you wish to convert concentration back to mole, so concentration times volume. All right, concentration times excuse me. So concentration times volume. All right, so times volume. Again, it's actually in the M cube. Then you'll have mole. All right. Now, if you got this, then actually we can solve the left-hand side. I already show to you there are 4 problems that we are going to solve. All right. So the first one is actually let me clear this side. So I have a plenty of oops, sorry. I have a plenty of space for you to follow. All right. So for the first one, all right. So I'm going to start from the easiest one. All right. So let me begin with this one. What weight of calcium carbonate will dissolve in 100 cm cube of 0.2 mole per dm cube of HCl? So what you need to do is actually you write the equation for this reaction, right? So you have a you have Ca, right? Calcium carbonate. Then the chemical formula for calcium carbonate is CaCO3 plus HCl. It will give you, look at this one. If you have a carbonate, then one of the product, and then you react with H, then one of the product is always carbon dioxide and water. It's always like that. Okay. So, and then the other one, if you're confused, just check the charge. So you can actually pair them, right? You can pair. So Ca and Cl, and then H, and you have a 2 minus and H plus. So you'll have then you'll have a CaCl2. Okay. So if I erase this, all right. Excuse me. Sorry. If I erase this one, then basically you can see that uh, I have a Ca and Cl2. Okay, all right. So I need to balance, of course. So I put 2 here because I have 2 Cl, and then I have 1 carbon, but I have a 3 oxygen and 2 hydrogen, and then 1 chlorine and 1 Ca is already balanced actually. So information is 100 cm cube of HCl. So the thing is, whenever you're dealing with the stoichiometry, you need to convert all to mole. So this one is actually, you convert to mole. So you have a 0.1 dm cube, and you times 0.2 mole per dm cube. So you cancel this, then you'll have a 0.02 mole of HCl, right? So you need to find the mass of calcium carbonate, so this one. So for 2, so for 2 HCl, you have 0.02. For 1, it means that you have half. So half of 0.02, so it's actually 0.01 mole. Okay, and then you multiply by calcium carbonate. Calcium carbonate, the molecular formula of calcium carbonate is actually 100. All right, so I now have 100. So Mr is actually 100 gram per mole. Okay, I cancel this one, is actually mole, then I have a 1 gram. Okay, is that clear? So this one is actually it is actually Mr of calcium carbonate, which is 100 gram per mole. Okay. Okay, next I'll just erase this one. Okay, so let me begin with the other questions, which is this one. 25 cm cube of sodium hydroxide reacts with 50 cm cube of solutions sulfuric acid. What's the concentration of sulfuric acid? Most of the students, when they encounter this question, they will write the equation, right? So I give you, or I submit to you the secret. You just need to know to follow this one. NOH times volume OH, okay, times concentration of OH equal to NH plus times VH plus times CH plus. So what's N? N is actually number of hydroxide. In this case, you only have a 1 hydroxide. Okay, for example, you have a magnesium hydroxide. Magnesium hydroxide, magnesium hydroxide, you have a 2OH because you have a MgOH2, then it becomes Mg2 plus and 2OH minus. So in this case, you have a 2OH. All right. Next, meaning if you have this, then you will have 1 OH here, and then you multiply by 25 cm cube of NaOH, and then times 0.1 equal to number of H plus. In this case, you have 2H. All right, so 2 times volume is 50 cm cube times concentration of H plus, right? So what you need to do, you can cancel this one. So cancel, right? And then it's actually 2, right? So now I have 4, and then this one is 0.1. CH plus. So concentration of H plus will be 0.1 divided by 4, which is 0.025. Please take note here, I don't even need to change the unit for OH, the volume of OH, because basically I can cancel that one directly. So instead of writing the chemical equation, this way, I presume is the fastest way to tackle these questions. All right, so you don't need to, you need to get this equation on your answer sheet, or when you do this one. All right, so you need just only check the number of H plus and OH minus, and then you don't need to convert the volume to the m cube. All right, so next is, let me erase this one so you can have a more point of view to see the screen. Okay, so next I have a number one, what volume of carbon dioxide will be produced if 100 HNO3 is added to excess sodium carbonate. So sodium carbonate is actually Na2CO3, and then you have a HNO3. All right, so remember, so you have a H plus, and then this one goes there. Okay, so you'll have a NaNO3 plus H2O plus CO2. Remember, when you have a carbonate, then the product is always water and carbon dioxide. So you are asked what the volume of carbon dioxide. So this one. So what is the volume of CO2, right? Okay, so you need to do is actually you convert everything to mole. So it's actually the keyword that you need to have when you encounter the questions about the stoichiometry. So you convert this one to mole. So I have a 0.1 dm cube times 0.2, which is 0.02. And then before that, I have to check whether this one is balanced or not. So I have a 2Na, and then 2, and then O is actually 6 plus 6 plus 1 is 7, 7 plus 2 is 9. So here you have a 6 plus 3 is actually 9. So it's already balanced. So now I have a 0.02 mole of HNO3, right? So it means that this one is for 2 moles. So 0.2 is for 2 moles. For 1 mole is actually 0.01 mole, right? Now, volume at RTP. So you just multiply the mole with the volume. So mole per dm cube, sorry, dm cube per mole, excuse me. So dm cube per mole, and then you will have dm cube per mole. Then you will have 2.4. Okay, so this one is actually 0.24, right? dm cube. Okay, that's the solution. So you need to see, and you need to convert everything that you have in mole, all right, and then you use stoichiometric equations to find the answer, all right. And lastly, I have a problem here for the formations of sulfur trioxide from sulfur dioxide and oxygen, all right. So here I have the reactions between that. So what volume of sulfur trioxide will be produced by complete reactions 100 cm3 of oxygen with sulfur trioxide? So here you have 100, so oxygen is 100 cm3, but then the ratio between SO3 and O2 is actually 1/2, so meaning that you also have a 200 cm3. Okay, so remember that ratio, all right, is actually the same as the coefficient. So if you have a half here, then this is 1, meaning that ratio between SO3 and O2 is actually 1:2. So for example, if you have a 100 of O2, then you'll have a 200 of SO3. That's it. All right, so I hope you enjoy this video. Then thank you so much for watching.